Hey guys, this is lesson 6.1. Today we're going to be talking about solving and graphing inequalities, and I'll show you how to do that today. Okay, let's get started. So today we're going to be talking about inequalities, which really, inequality is exactly what it sounds like. Inequality means not equal. Not equal. So if I say something like x is equal to 4, that does not count as an inequality because I have said something that is equal. So an example of an inequality might be down here. I have an example, x is less than 3. This is an inequality because I am talking about any number that is less than 3 as this inequality. So an inequality is an equation that represents all solutions to the inequality. To graph an inequality, use an open circle, and it's talking about the open circle. This open circle is talking about right here. Use an open circle on a number line for less than or greater than and a closed circle for less than or equal to and this symbol for greater than or equal to, right? And so this closed circle, again, is talking about, like in this picture, right down here, okay? So go ahead and write this example down, write this definition down, and we'll give you a couple examples of how to do this coming up. So if you want to write this down, go ahead and pause this example. Otherwise, I'm going to be switching to the next slide. Now let's write an inequality that represents this graph. There are a couple things that I notice. I notice that the shaded portion of the graph, or this number line, is to the left of the number 3. And I also notice that 3 is not included. So if we look at what we just wrote down in the notes, if I notice these things, that means I need to write an expression for all the numbers to the left of 3 on the number line, but not including 3 itself. So before we said symbols like less than or greater than were the ones that do not include the number that it's referring to, and less than or equal to and greater than or equal to do include the number that it is referring to. So since this does not include, this means I am going to be thinking about just less than or greater than. So now let's ask ourselves, am I talking about numbers that are less than or greater than 3 here? Well, this shaded portion are all numbers that are in fact less than 3. 2 is less than 3, 1 is less than 3, 0 is less than 3. So I need to write an expression to signify all the numbers that are less than 3 but not including 3. And the way we write that is by saying x, that's referring to our system of numbers, x is less than 3. Now, why did I write it in this direction? Well, the way I like to think about it is the alligator eats the bigger cookie. In the case of math, the alligator eats the bigger number. So since I write it this way, this would read x is less than 3. If I were to write it this way down here, this would say x is greater than 3. So that's not going to work because I'm talking about all the numbers that are less than 3. Okay? Let's move on to the next slide. Now here's one more, and I realize my number of interest in this case happens to be 4. So whatever my expression is in, my number of interest here is 4. Let's take a couple things that we notice. Okay, so notice that I'm referring to numbers that are, let's see, greater than or less than 4. And it looks like since it goes to the right on the number line where the numbers increase, these are the numbers that are greater than 4. Okay. But I also notice that it includes 4. So I need to write an expression that is both greater than 4 but also includes 4. And if I remember again, that means I am either going to use one of these two symbols because this line underneath right here is a line that means or equal to. These lines right here mean or equal to. All right, so I need to write it in some way. So I have x, and I need to put is greater than or equal to 4. So what is my symbol going to look like? Am I going to choose this symbol or this symbol? Which one am I going to do? And if I use this symbol, let's see. If I used this symbol, this would say x is less than or equal to 4 because again, the alligator eats the bigger number. So 4 being bigger means x is less. So x is less than or equal to 4. So that's not going to work. We're going to have to write the other one. And that's going to be my answer. All right, so this is my expression for this graph. So we just saw some examples where we take the graph and write an expression. Now let's do the reverse. We're going to take the expression and write a graph for it. So what do we notice here? Our number of interest is going to be negative 0.5. In order to put this down, let's put some labels on our graph. So if this is 0, this would be 1, 2, 3, and so on. And this would be negative 1, negative 2, negative 3, and so on. I could keep labeling those if I want to. I notice that my symbol here means x is greater than, right? The alligator eats the bigger cookie. X is greater than, but it's not including because there's no line underneath. So not including negative 0.5. So where is this negative 0.5 at? I'm going to go ahead and I'm going to make a circle right at where negative 0.5 would be. It'd be right between 0 and negative 1. I'm going to make a circle. And then since it's greater than that, I'm going to draw a line kind of like this. And then I'm going to shade the regions that my inequality occupies. I am not going to shade in the portion inside the circle because if I was to shade it in, if I look over here, an open circle refers to x is greater than that number. A closed circle, which means I have it shaded in, would mean, and let's shade these in too, a closed circle like this would mean x is greater than or equal to that number. So this would be my answer for this picture. So not too difficult, but drawing the graph is probably going to be the most time-consuming thing. Now I don't have just an equation that I need to graph. I need to first and foremost solve this equation. So in order to graph an equation, I need some expression that looks something like this. X is greater than something, or x is less than something, or x is greater than or equal to something, less than or equal to something, or x is greater than or equal to something. All of these things have in common that x is solved for. Here, x is not solved for And what I need to eliminate is this x minus 5 and the x minus 5. I'm trying to isolate this x. Okay? So let's isolate it. How would we normally solve this if this said x minus 5 equals negative 3.5? If you think about it for a second, the answer would be clear. We need to add 5 to both sides to get x is equal to 1.5. Well, this is no different. I'm going to treat my inequality symbol right now no different than I would treat a regular equal sign. So what we need to do, first I'm going to erase this work. And now we just need to isolate x. So again, before, I'm going to add 5 to both sides to get x is greater than negative 3 plus 5, which is 1.5. Now it says I need to graph the solution. So in red, I'm going to graph the solution. I need to graph it. Well, how do I graph this? Let's go ahead and let's make a number line. And I always start with my point of interest. My point of interest is 1.5. So rather than plotting 1.5, I'm going to plot 1 and then 2 because 1.5 would be perfectly between it. And then just for good measure, I'm going to put 3 and 0 on both sides. You can make these numbers however you want. I usually just try to make the center of my number line this number right here. So this is 1.5. I'm going to just label that how it is. Now it says x is greater than 1.5. So I'm going to circle 1.5. And since this is not an or equal to symbol, this means it's going to be an open circle, which means I don't shade it in. And since it's greater than means it's going to be to the right on the number line. Because as we go to the right, our numbers get bigger. So I'm going to just draw a line like this. And now I need to shade in the regions of this graph that apply. So I'm not shading in the circle at 1.5, but I'm going to shade every other point that is under my graph. So this would be sufficient to answer this problem. My first part of my answer is, I'm going to circle these in black. My first answer is x is greater than 1.5. My second part of my answer is the number line that shows my solution. And here's our last example for the video, but this is an applied example, a word problem. Let's just read it together. You're checking a bag at an airport. Bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Find the possible weights marked W in pounds that you can add to that bag. Normally people would think about this problem and say I can add up to this many pounds, but we're going to express this as an inequality. So first, before we get started, we need to figure out what this is talking about. So we need our bag to weigh no more than 50 pounds. This is an important piece of information. If you do that at an airport, you get fees, and people usually like to keep their bags beneath a certain weight so that they don't have to pay extra money. So what this is saying, no more than 50 pounds, how else can we say that? Which symbol is going to fit? Is it going to be less than? Is it going to be greater than? Is it going to be less than or equal to? Is it going to be greater than or equal to? Which one of these four is going to fit for the expression no more than 50 pounds? The one that's going to work here is going to be less than or equal to, right? If you think about it, if I have a bag that is less than or equal to 50 pounds, that means my bag weighs less than 50 pounds or it's equal to 50 pounds. And since this problem says no more, that means it can include 50 pounds but not exceed 50 pounds. All right, so how would I write a bag that can weigh no more than 50 pounds. Well, I would normally write that as the weight has to be less than or equal to 50 pounds, right? But there's one more addition to this problem. So in purple, we will look at that. Your bag weighs 16.8 pounds. We need to find the possible weights in pounds that you can add to the bag. So we have to set up an expression and then solve for this. So think about it. The weight has to be less than or equal to 50 pounds, and you already have 16.8 pounds. So how we're going to write that is like this. I have the weight of my bag plus the 16.8 pounds that I already have in the bag, and that combined has to be less than or equal to 50 pounds. So now we have an expression that we can solve. So if I go ahead and I solve for W here, I'm going to subtract 16.8 pounds from both sides. And so my answer after I do that would be W is less than or equal to, and if I punch in 50 minus 16.8 into my calculator, I'll get 33.2 pounds. So this is the expression that I am going to be graphing on my number line. So let's make a number line. So if my number of interest is 33.2, I'm going to go ahead and I'm going to mark a couple key points like 33, 34, maybe 35 right here, maybe 32 right here for good measure. Okay, and my number of interest is going to be 33.2. Okay, and my number of interest is going to be 33.2, which I will label right here. And I'm going to circle my number of interest. And it says it's less than or equal to. So less than would be to the left. That's less than on the number line. The numbers get smaller as I go to the left. And it says or equal to here. Or equal to. That means that when I shade in my numbers to the left, I also need to shade in my circle to indicate that I can add 33.2 pounds also. So my two answers, first and foremost, is going to be W is less than or equal to 33.2, and my graph is right here. So here are a few examples. I hope this made sense. If you'd like to get started on the homework, I'll put it on the screen right now.